Hello everyone. If you dream it, then you can definitely do it. With this motivational thought in mind, let's begin today's video. We will be covering very important topic, that is maxima, minima. After the reduction in the course, this topic altogether becomes more important, right? To understand the concept, first of all, let's understand what is maxima and what is minima. When the moment we use the word, the moment we say the word maxima, what comes to our mind? It comes the highest value. I can say the highest value is the maximum value, right? Suppose we have a curve like this. So I say this is the value after which the curve is not increasing. So that is the maximum value. I say this is the lowest value after which the curve is not going further down. So it means this is the minimum value, right? So this is the literal meaning of the word maxima and minima. So what CBSE says, first of all, there are certain type of questions asked where you have to answer directly on the basis of the observations, right? Now, and after that, we will be doing certain tests which will help in deciding how we have to find the maximum and minimum value, right? For the 1 marker questions, what we have, like whenever we have a function like x square, we always say it is greater than equal to 0, right? Whenever it is x square, it is always greater than equal to 0. So it means the minimum value for x square is 0, right? Similarly, if I have mod x, so whenever I have mod x, again it is greater than equal to 0. So what does it mean? It again means the minimum value is 0, and as such these are functions which we don't know up to what value they will go unless and until I don't know the range, right? So over here we can say this, for this function also the minimum value is 0. Similarly, I have question number 1, first part over here, 2x minus 1 whole square. So what we will do is we will say 2x minus 1 whole square is greater than equal to 0, right? Then what I'll do, I'll add 3 to both the sides. So if I add 3 to both the sides over here, what will this will be my original question, and this will be greater than equal to 3, right? So what does it mean? That the minimum value is 3 and I cannot find the maximum value. Over here, I know the minimum value will be 3 when this whole square will be 0. When this whole square will be 0, when x is equal to 1 by 2. So I can say I can find point is half at which the minimum value is 3, right? No maximum value in this case. Similarly, I can do the third part. For third part, what I'll do is I'll just write x minus 1 whole square I know is greater than equal to 0, right? Then if I put minus sign on both the sides, what happens? It will be less than equal to 0. We know the sign inequality changes when we multiply by the minus sign, right? Now, what we will do is we will just write, we will add 10 on both the sides. So if I add 10 on both the sides over here, so what will this be? This will be my function which is fx, and this is less than equal to 10. So what does it mean? 10 is the maximum value, and at what point will 10 be the maximum value? When this whole square will be 0. So when will this be 0? When x is equal to 1, right? So this is how I can find the maximum value. Similarly, given a function like this, what we will do, we will complete the whole square. So over here, if I complete the whole square, what will I get? I'll get this as 3x plus 2 whole square, right, minus 2. 3x plus 2 whole square minus 2, right, if I complete the whole square. Now again, I'll say this is greater than equal to 0 if I add minus 2 on both the sides. So we will have minus 2 as the, like this, right? So we will say this is whole square is greater than equal to 0, minus 2 on both the sides. So what will be? This is the function is greater than minus 2. So minus 2 is the minimum value, right? And again, at what point? It will be at minus 2 by 3. Now, if I observe fourth part over here, so for fourth part, what I have, as such, we don't have any idea of cube, like at what interval it will increase or decrease. So over here, for fourth part, we will say no maximum, no minimum value, right? Now, moving on to question number 2. So one type of questions where you have squares. Another type of questions will be question number 2, like when we have modulus. So again, when we have modulus, what we will say for the first part, if I say for the first part, I'll say mod x plus 2, right? Again is greater than equal to 0. I'll just subtract minus 1 on both the sides. So what I'll get? I'll get this as the original function is greater than minus 1. So again, minus 1 is the minimum value, right? So exactly on the same line as first part, we will do the second part where we will say mod x plus 1 is greater than equal to 0. If I put minus sign, this particular inequality will get invert. Then if I add 3 to both the sides, I'll get gx is less than equal to 3. So it means 3 is the maximum value and I'll say no minimum value exists. Now moving on to third and fourth part, these are the types which are usually asked in exam. In place of sign, you can have cos as well. What is given? You have to find the minimum maximum value of this. And for the sign, we know that sign always lies between minus 1 and 1. So if I add 5 to all the three sides, I'll get 4, hx and 6. So it means the minimum value is 4 and the maximum value is 6, right? Exactly on the same lines, I'll do this particular part. Over here also, I'll say sine 4x is between minus 1 and 1, right? Now what I'll do, I'll add 3 to both the sides. So this will be 2 over here and this will be sine 4x plus 3 and this will be 3 plus 1 will give me 4, right? Now if I take mod of both the sides, then also the answer will be same and this will be my function over here. So what will I say? I'll just say had it been negative, then mod would have made it positive, right? So now I will say it is between 2 and 4, right? A very important point that everybody has to know that this is the angle only 4x. Had the angle been this, like the question would have been this, then my minimum maximum value would have been minus 1 to 1, right? So we have to be very careful, vigilant as to sine, the angle of sine is what expression, whether the expression is added after applying sine or it is for the angle, right? So now if I move on to the fifth part, it says whenever we have like open interval minus 1 to 1. So over here, I don't know the minimum value as well as the maximum value, right? So what we will do for this, I cannot find the maximum or minimum value. But had it been like minus 1, 1, then I would have said that 0 is the minimum value and 2 is the maximum value, right? So it depends on if the interval is closed, then I can conclude the minimum and maximum value. But if it is open and we don't know the nature of the curve, so it means no maximum, no minimum value exists, right? So this is how we will be doing all these one marker questions. Then moving on to the next question, now we will be learning the rules. So first of all, we will learn the first derivative. So moving on to the first derivative test, as you can see it over here, first derivative test. This is as such not used in almost most of the questions, but still since it is there in the NCERT, so we are supposed to do it, right? So what we have, what is the working rule of the derivative test says? It says that given a function, we will find the first derivative as it says, we'll equate it to 0 and find the turning points. Let ABC be the turning point. If for x is equal to a on moving from left to right of this point. When we say left and right of this particular point, what does it mean? It means a value which is slightly less than the given value. Suppose x is 2, suppose a is 2, then if the left value will be 1.9 and the right value will be 2.1. I'll put the left and right value in the derivative, right? If the sign of the derivative changes from positive to negative, then I'll say that it is point of maxima. As you can see over here in the graph, if the value changes from positive to negative, so the slope changes from positive to negative, so it means this was the highest value. Similarly, if the case is reverse, it means it is changing from negative to positive. It means this is the minimum value, right? So based on this, we will say the same thing applies to point B. So I'll say the point is point of minima, and if I put that particular point in the original function, I'll get the minimum or the maximum value. Suppose in case when the sign does not change, on moving from left to right, either I am getting both negative or I am getting both positive, then in that case, I'll say my test has failed. Then I need some other test to verify this particular condition, right? So this way we will be moving. I'll discuss one example with you, that is example 29 over here, which says fx is x cube minus 3x. So if I differentiate, I'll get 3x square minus 3 and I'll get 3x minus 1 x plus 1. So what will be the points? Plus 1 and minus 1, right? So what I'll do is I'll just move for this particular point and let's say what sign we are getting, right? So I'll just take point as 1 first of all. So if I take x, left of 1, what does it mean? Left means slightly less than 1. Let's take it as 0.9. So I'll put it in the derivative over here in the factors. So if I put 3, x minus 1 and x plus 1. So if I put over here 0.9, this factor will be negative. So it means the sign is negative left. Then if I take right side, right point I am taking as 1.1. So if I put 1.1, definitely this particular factor will be positive. So it is moving from negative to positive. It means this is the point of minima, right? So this particular point will be point of minima. The point A is over here 1, right? And if I put f of 1 in the original function, so I'll just get the value. If I put 1 here, so it will give me answer as 1, right? Now next is minus 1. So if I take minus 1 over here for this, so if I take x as minus 1, the left will be minus 1.1 and the right will be minus 0.9, right? So minus 1.1 over here if I put, so this will be negative and this will also be negative. So this will come out to be positive. Now if I take minus 0.9, this will be negative, this will be positive. So all the more this is negative, right? So if it is minus 1, then it is moving from positive to negative. So what does it mean? This is the point of maxima. And if I put minus 1 over here, what will I get? I'll just get it as minus 1 plus 3 and plus 3. That is 6 minus 1 will give me 5. So the maximum value is 5 and the minimum value is 1, right? So this is, so moving on to the second derivative test, what we have. The second derivative test says, suppose I have a function, I'll find the first derivative, equate it to 0 and find the critical point. This step is same for the first derivative, for increasing, decreasing, for the second derivative, right? Then since the name is second derivative, what I'll do, I'll find the second derivative, and in the second derivative, I'll consecutively put all the points. If at this particular point, the derivative, sign of the derivative, I don't have to find the value, I just have to focus on the sign. The sign of the derivative is greater than 0, it means this is the point of minima, and f of a will give me the minimum value. Similarly, if at b it is less than 0, the sign of the second derivative, then I'll say it is point of maxima, and f of b will give me what? The maximum value. Similarly, if I have point c at which the derivative is 0, no change in the sign or no sign, then we will say the point is point of inflection. As in the first derivative, we said the first derivative test has failed, because after second derivative test, I don't have any other test. So what I'll say, that the point is point of inflection. Suppose I'm doing second derivative first and I'm getting a point of inflection, then I'll just say the second derivative test has failed, and I'll do that particular point, verify the point by first derivative. And if the first derivative also gives me the same result, no change in sign, then only I'll conclude that it is point of inflection. So what is the thumb rule? That we have to verify by both the test, if we are getting a point of inflection, that it is actually a point of inflection, right? So moving on to the question, how we will be doing the questions of this type. We have this question of exercise 6.5. This is question number 3. Now what it says, find the local maxima and minima. Now when the word local is used, it means we have to find within the domain or in the open interval the maximum and minimum value of the given function, right? So over here, fx is x square. As we concluded in the first part that it has 0 as the minimum value at 0, right? So we will not do that particular question. I'll move on to the second part. So over here, if I do the derivative, right? If I do the derivative of this particular function, what will I get? I'll just get it as 3x square minus 3. So if I take x square, if I take 3 common, it will give me x minus 1 and x plus 1, right? So I'm getting 2 points, x is equal to 1 and minus 1. I'll find the second derivative. So if I find the second derivative over here, I'll get 6x. So if I put 1 over here in the second derivative, I'll just get 6. So it means it is greater than 0. So 1 is point of minima. So if I put 1 over here, what will be the minimum value? Minimum value will be 1 minus 3, that is minus 2, right? Similarly, if I put minus 1 over here, so minus 1 will give me minus 6. So it means minus 1 is the maximum value. Minus 1 is the point of maxima. And what is the maximum value? If I put in the original question minus 1, what will I get? I'll get it as minus 1 plus 3, which is 2. So maximum value is 2 and minimum value is minus 2. So this is how we will be solving. Let's move on to the trigonometric question over here. So what we have, that is sin x plus cos x. So when we have sin x plus cos x, so and it is for the open part. So when we have sin x plus cos x, I'll just find the derivative. Sin x plus cos x will give me cos x minus sin x, right? Then what we will do is, we will equate it to 0. So I'll just get cos x is equal to sin x if I equate it to 0. Then I'll just divide by cos x on both the sides. So I'll get tan x as 1. Since it was open interval 0 to pi by 2, it means we are in the first quadrant. So I'll just say x is pi by 4, right? So we will find the second derivative at this particular point to check what is the sign, whether this point is point of maxima or minima. So I'll just get it as minus sin x and minus cos x. So I'll just take minus common, sin x plus cos x. We just remember we only have to focus on the point, right? So on the sign, right? So if I put pi by 4, both the values in the first quadrant will be positive. So altogether we have minus sign outside. So it means f this point, so we have minus sign outside. So it means this is point of maxima, and what will be the maximum value? We can just put in the original function and find the maximum value, which will come out to be root 2, right? So on the same lines, we can do the next part. So what is the next part? Next part is, we have sin x minus cos x, and the range is 0 to 2 pi open interval, right? So if I write the derivative, what will be the derivative? It will be cos x plus sin x, right? So I'll just get tan x is equal to minus 1. So now tan is negative in the second quadrant and in the fourth quadrant. So what I know, the value 1 is at pi by 4. So pi by 4 in the second quadrant will give me what? So pi by 4 in the second quadrant means pi minus pi by 4. So that will be 3 pi by 4, right? And in the fourth quadrant, it will be 2 pi minus pi by 4. It means it will be 7 pi by 4. So I don't have to take it as 3 pi by 4 and 7 pi by 4. I'll just say these are the values pi by 4 in the second quadrant and in the fourth quadrant. So I'll find the second derivative. So what will be the second derivative? It will be minus sin x plus cos x over here, right? So if I put the value 3 pi by 4, just what is 3 pi by 4? The value of pi by 4 in the second quadrant. Second quadrant sign is positive. So this will give me negative sign, and cos is negative. So this will give me negative sign. So it means 3 pi by 4 is the point of maxima, right? Similarly, 7 pi by 4, if I put 7 pi by 4, fourth quadrant pi by 4, fourth quadrant means sign is negative. Negative, negative will give me positive for 7 pi by 4, and cos is positive. So this will be positive. So over here, this is point of maxima and this is point of minima over here. We will put in the original function to find the value, right? So this is how we will be doing this particular question. Now let's move on to the next question. So if I see the next question over here, same lines, we can do all the questions. Like over here, we have x cube. We'll just differentiate same way this way. So this is the rule on which we will be working, right? So other parts, all the students can pause the video, try, and just type in the comment box if you have any doubt, right? Now, question number 4, it says, prove the following functions do not have maximum minima. So when we cannot find any turning points, then we can say we don't have any maximum minima. So for ex, the derivative is ex. I know this will never be 0 for any of the x. So again, I cannot find maximum minima. Also, the graph is an increasing function. So unless until some interval is given, we cannot find the maximum or the minimum value. Similarly, for the log x, it is 1 upon x, which will never be 0 for any of the value. Hence, it is, we cannot find maxima or minima. Over here also, if I differentiate it, what will I get? I'll just get 3x squared plus 2x plus 1. And I'll just see that it has no real roots. No real roots means again I cannot find any turning points, hence no maxima and minima, right? Then moving on to question number 13 of miscellaneous exercise. This is very important. Here I'll be using both the first derivative test as well as the second derivative test to emphasize on certain points. So observe very carefully. So what we have, this is the question over here given. So I have written the derivative. So if I do the derivative, we will do it by product rule. So x minus 2 whole 4 will give me 4x minus 2 cube and x plus 1 whole cube as it is. Then 3x plus 1 whole square, x minus 2 whole 4 as it is. Then what we'll do, we'll take common. So what factors will I take common? I'll take x minus 2 whole cube and I'll take x plus 1 whole square common. So we will have 4x plus 1 and 3x minus 2. If I multiply it up, I'll get 7x minus 2 over here. So if I equate it to 0, my 3 critical points will be 2 minus 1 and 2 by 7. Now we have to find the second derivative. Again, we have to be very careful. So by product rule, if I find the second derivative, I'll use it over here. So first I'll differentiate this. I'll keep these two functions as it is. So 3x minus 2 whole square, x plus 1 whole square as it is, 7x minus 2 as it is. Then I'll just write x minus 2 whole cube as it is, x plus 1 whole square derivative will be 2x plus 1 and 7x minus 2 as it is. Then the derivative of 7x minus 2 will be 7 and these two factors will be as it is. Now out of this whole lot, I'll just take x minus 2 whole square common and x plus 1 common, right? So we will have x minus 2 whole square and x plus 1 common. So what will be left, I have written it within bracket. Now we will not solve it further, right? What we will do is, we will simply find, put the value and see the sign of the second derivative. So if I put 2 over here, you can observe x minus 2, if I put 2 over here, this will be 0. The whole factor will be 0. So it means the derivative test has failed. Similarly, if I put minus 1, again this whole factor will be 0. Everything is in multiplication. So I am getting 2. If I say for 2 points the test has failed, so I have to do the first derivative test for these two points, right? Now if I put 2 by 7 over here, so if I put 2 by 7, this particular factor and this particular factor will be 0, right? This is whole square, so it will not give me any sign. So 2 by 7, this will be positive, and over here 2 by 7, this will be positive and this will be negative. So on the whole it is negative, so it means 2 by 7 is the point of maxima. So now we have to check by first derivative the signs of what? Whether 2 or minus 1 are the points of inflection or they are points of maxima or minima, right? So what we will do? We will just do it by first derivative test, right? So over here, x is equal to 2. So left point of x is equal to 2 is 1.9. So if I put in the first derivative, right? So in the first derivative, just see over here. So this is my first derivative and you can see the screen as well. So 1.9 if I put over here. So this particular factor will be negative, right? This will be positive whole square, it will not have any effect. So we will not see x plus 2 whole square. So this factor is negative and for 1.9 this is positive. So it means the sign will be negative, right? Now if I put 2.1, this will be positive and this will be positive. Sign is positive. So if we are moving from negative to positive, it means negative to positive. So x is equal to 2, which was coming out as the point of inflection by second derivative test, has come out to be the point of minima, right? So 2 by 7 is the point of maxima and 2 is the point of minima. Now we have to check for minus 1. For minus 1, is that the point of inflection, or again we will be getting maxima or minima, right? So for minus 1, what I'll do, left value will be minus 1.1. So this factor will give me negative value and this will also give me negative value. Negative into negative will give me positive, right? Then 0.9, this will be negative and this will again be negative. So again positive. So no change in sign means x is equal to minus 1 is point of inflection. So this is what it was asking. For maxima, it is 2 by 7. For minima, it is 2. And inflection point is minus 1. So this is very important question where we are using both the rules. So this can be there in exam for 4 marks. So if we are getting 0 by one derivative test, or we are getting a point as point of inflection by one derivative test, then we have to do it by the second derivative test to ascertain whether that particular point is actually the point of inflection or